Welcome to this presentation on spaced repetition. I'm really glad that there are a bunch of people who are interested in this because, you know, me and Zander, we're really into spaced repetition. We're kind of nerdy about it, and any opportunity we get to do a presentation like this is like a good day for us. Thanks for coming. And yeah, like I said, the talk was a little bit dry with just me and the slides. It felt like a lecture or something. So I brought in my magnificent Californian pal to spice things up a little bit, make it a little bit more conversational, hopefully more interesting for you, the viewers. I just want to say thanks really quickly to all the organizers as well, because I don't know, the Obsidian community is worthy of some sort of like case study in a community organization or something like that, because everything was just really well organized. So thank you to everyone who was responsible for that. So firstly, who are we? My name's James. You can find me on Twitter at @experalearning, and I also have a YouTube channel, Incremental Learning, where I talk about things like spaced repetition, incremental reading. I have a little bit on Obsidian and stuff like that. And then Zander, you can find him on Twitter at ZDRKS. And we also have this quite geeky and nerdy podcast called Golden Nuggets Podcast, where we talk about spaced repetition systems and things like that. So let's get into it. The reason we decided to make this whole spaced repetition presentation was because there's a bunch of like growing interest in spaced repetition from the personal knowledge management systems communities, including Obsidian and Rome. I noticed that recently there's like, I wrote this plugin, and while I was writing the plugin, I was looking at other plugins, and I saw that there were multiple spaced repetition plugins available for Obsidian, which is really cool. And in the Discord, there's always these questions about whether to use spaced repetition or not, how to use it alongside Zettelkasten systems and stuff. There were these cool videos as well. And Zander, I think you've used like the plugins for Rome and stuff as well, right?
Yes, I've used them a little bit. And of course, when you're working in a system like this, the plugins are always going to be somewhat limited, but there are a ton of powerful possibilities. So yeah, I've used them. Right.
So all of this basically just points towards this exponential adoption of spaced repetition that we've been seeing over the past few years, especially, which Piotr Wozniak, the inventor of spaced repetition, has written about in this article in 2018. You should go and check out if you're interested in it. So what is spaced repetition? Essentially, it's this algorithm invented by Piotr Wozniak, and it basically intends to solve the problem of forgetting. So what's the problem of forgetting? Very simply explained, it's that feeling you got when you were at school, if you went to school, that is, that during the semester you'd learn all of this stuff, and then as soon as it got to the summer holidays, your knowledge that you acquired during the semester would just decay. And by the next semester, you'd require all of these like refresher classes just to gain back all of that acquired knowledge that you'd lost over the summer. And actually, this is kind of a ubiquitous process because Zander, you didn't go to school, right? But yeah, I imagine that you still face this problem. Is that correct?
Oh, yeah, absolutely. That's why when I was a kid, like 12, 13 years old, I was extremely bothered by this. Like I would try to read and then I would recognize like, oh, I'm forgetting everything. And it felt like kind of a waste of time for me. So that's how I discovered Anki and stuff like that when I was quite young.
Exactly. So this whole spaced repetition thing, the whole point of it is to calculate these optimum intervals between active recall repetitions to maximize your memory stabilization. Basically, what I'm talking about here is that by actively recalling information, this produces a memory effect that strengthens the memory. So it persists longer in your memory before it needs to be repeated again. And by sort of abusing this memory principle, you can retain kind of a staggering amount of information in your memory for very low costs over a lifetime. And so that's the whole thing that the spaced repetition algorithm is optimizing for. Its whole goal is to maximize retention of knowledge and minimize the cost in terms of time from repeating this information, right? So here's an example of some of the things that you'll be repeating. This is how you do the active recall in spaced repetition systems. You basically have a question, which is like a prompt. For example, here I have a very simple example, just a language learning question. It's telling me to actively recall from my memory how to say memories in Chinese, right? And over here I have a slightly more interesting one, which is asking about what Bertrand Russell thought about mathematical systems and like what about a mathematical system was like a kiss of death. So it's a more interesting item. You don't just have to have these very simple A to B associations between language learning items. You can also have almost like metaphorical, conceptual based questions as well, right, Zander? Like there's a huge sort of variety in the types of items you can have.
Absolutely. And that's, I think this is such a core point, and it's good that you're introducing this so early on. If you guys haven't used spaced repetition before, oftentimes what people tend to use it for is what they refer to as facts and figures, or these kinds of things. And it is very useful for those things if you employ it well. But it's useful for conceptual ideas and these kinds of things. But people are, in my view, a little bit too close-minded about where these spaced repetition prompts can apply. And you can use them in your own creative work. You can use them for personal development. You can use them to think about, memories from your own life, or refresh things, or perform tasks, or advance a project, or figure something new out. Anything like this, you can use them for all kinds of things. And it's important that serves as the basis of someone's understanding of the spaced repetition prompt. It's not just for facts and figures. It's essentially, as Andy Matushak would describe it. I don't know if you guys have heard of him, but if you haven't, it's worth looking his stuff up. But he describes spaced repetition prompts as essentially a micro task for yourself. And it can be anything. Essentially, it's the scheduling is what matters. And the micro task of it, sometimes you'll be recalling a fact. Sometimes you'll be generating a creative idea about a particular thing, so forth. So I think that's a crucial point.
Exactly, yeah. You described that really well, yeah. So, and then that was the question side, and here's the answer side. This is the part that you're actively recalling and then giving yourself a grade to determine the next interval of the question. So when it will be shown to you next. If you were able to recall it very easily, you'll get a much longer interval because it signifies that the memory was stronger. So you don't need to repeat it that soon. You can wait for a longer period of time and then repeat it. So then you see that there's an optimization there where you're not wasting time reviewing information that you already know because it's already stored in your memory. You don't need to review it. You only spend time reviewing those repetitions that are the most difficult, the ones that you struggle with the most, right?
Yeah. And also it's important to note, the longer the interval, the more the storage strength, so to say, of the memory is increased at successful review.
Right.
And so one of the corollaries of that is that if you review too often, sometimes you'll find that the memory doesn't last very long.
Yeah.
So like an example that I've observed, like just in ordinary life, people tend to notice this. If you binge watch a TV show, particularly one with a lot of characters, people tend to forget all the names of the characters. Whereas if you had been watching it week to week for 8 years, you wouldn't forget the names because you've had a much longer time to review those names. So people kind of know this intuitively. Not only does long intervals strengthen it, but short intervals weaken it. So anyway.
Yeah, that's a very good point. I like the example, and it's kind of counterintuitive because you'd think that reviewing something just constantly throughout the day, that would make something very easily retrievable for you and it would strengthen the memory. But that's that's simply not the case. And you can make an analogy there between like memory systems like spaced repetition and like bodybuilding. Like if you want to become a bodybuilder, one of the first things you learn is like you need to rest. Rest is like a really important part of the whole training thing. You can't just do bicep curls constantly all day and expect to get jacked, right?
Exactly. Yeah, it's certainly a through line in biological systems. Like there needs to be some development across time, and you can't just bunch it all together and expect the same results.
Precisely. So I couldn't help but include this because I thought it was cool. It's like an example of Woz's early experiments, Piotr Wozniak's early experiments into spaced repetition. And this is spaced repetition on paper from the 1980s. So he'd have his English words on the left, Polish words on the right, and then he'd cover over the English and answer what the Polish was, or vice versa. And crucially, he would also record the repetition history. So he even had like a paper database of all the repetitions he'd done over time, which was which became a really important part of determining the optimum interval. So yeah, quite interesting.
This man changed the world with his meticulousness.
He did.
It is absolutely, it is insane. He's such a careful thinker. Anyway,
Yeah.
go ahead.
Yeah, exactly. So yeah, the whole problem of forgetting thing that we just mentioned, the ubiquitous problem of forgetting, was the impetus for Piotr Wozniak to come up with this whole space repetition idea. He got really fed up with the never-ending process of forgetting. He wanted to learn biochemistry and physiology, and he would read books, make notes, and it would all be for nothing due to the process of forgetting. And yeah, it truly is ubiquitous because all memories are subject to forgetting, even the ones where you might feel like you'd be able to remember them for a lifetime. Even those are subject to forgetting. They can all be, that forgetting process can all be shown basically on this very simple graph for a simple single memory. On the first day where you learn something, day 0, the chance of recalling it is going to be very high, close to 100% on the day that you first learn something. But over time, over the subsequent days, the strength of that memory is slowly going to decline until it reaches a certain point at which retrieval is going to be very improbable and unlikely. And at that point, you can say it's been forgotten. So to give you an example of, you know, the ubiquitousness of this forgetting process, like I know, especially as a programmer, I know that there are programmers listening to this as well, so you can probably relate. Like often when I'm just sitting in bed at night, I'll come up with like either an idea or a solution to some bug that I've got in one of my programs. And often I assume that since I've come up with that insight, I've now got that insight. I've achieved it and now I've got it for life. But then, you know, as early as the very next day, it's just disappeared straight into the abyss, never to be found again. And it's impossible to reactivate those brain states to just achieve that idea, that insight again. So it's counterintuitive. And we have this sort of bias where we think we will remember things, but we just simply can't.
Absolutely. This is such a key insight because people sort of recognize intuitively, like we've talked about, that they forget things they've learned. Right?
Yeah.
But something that is more counterintuitive is the fact that you'll forget your own ideas and your own opinions and how you formed those opinions. It's like I have an opinion about X and it's my opinion. I thought of it. I used my brain and my network of knowledge and opinions to make a new opinion. Therefore, I won't forget it. But it's simply untrue. Like you're using source material. You're like you say, even just a raw idea about something that you know well. There is no guarantee. In fact, it's almost a guarantee that you will forget it if you don't write it down. And so that's just a side point. If you have an idea, write it down immediately. Because something Woz says, Wozniak, I apologize. In the community, everybody calls him Woz. But anyway, yeah, something he says is, if you don't write your ideas down immediately, the memory of it, you start to just remember that you had to write about a subject, not even that you had to write about the particular idea. So it starts dwindling immediately. And if you can have a piece of paper or a computer or an iPhone or something to capture your ideas immediately, that's always ideal. But anyway, the key insight is that nothing is exempt from forgetting.
Exactly. But while we're talking about the problem of forgetting, I think it's important to note that this problem is also the key behind the brain's greatest power, which is generalization. So we wouldn't want to get rid of forgetting altogether. You know, generalization, the ability to see instances of like observed data in the world and take their similarities, forget their differences and combine them into a more abstract representation, like a concept. That's key in abstract thinking, which powers all of science and mathematics. So if we were to get rid of forgetting altogether, Woz has this quote, the brain would be as dumb as a tape recorder, simply just recording all of the data it had seen without generalization, right? So we don't want to get rid of it altogether, but I don't think that's a concern. I don't think that would even be possible anyway, so yeah.
There's some people with that weird disease, hyperthymesia, I think it's called.
Right, yeah.
It tends to be quite an unpleasant experience from what I understand.
Yeah.
There are some things that you would rather forget, not even just for the sake of generalization. It's just you don't want to constantly have memories in the same level of fidelity as the original event. So anyway.
That's very true, yeah. So here's a really snappy history of the space repetition development. There were contributions from a bunch of scientists. Everyone's probably heard of Ebbinghaus in 1885. He showed that memory could be studied scientifically. And then between 1885 and 1985, when Wozniak did his first attempts to measure the optimum interval, the principle of spaced repetition was sort of invented and then forgotten, ironically, repeatedly, by multiple people. And it was really until 100 years after Ebbinghaus that Wozniak attempted to measure the optimum interval by investigating the impact of repeated review. This is an important point. Like, what happens to the forgetting curve for memories when you repeat the review over time, and when should you optimally space the reviews to maximize this memory effect, the flattening of the curve that allows the memory to persist in memory over time. So this
an important insight there, just real quick, is that Ebbinghaus, and maybe you'll touch on it here, but Ebbinghaus did a lot of experiments with essentially nonsense syllables, and a lot of spaced repetition research even today is centered around this cramming nonsense information into people's brains and seeing how long that lasts. But the crucial insight, at least in terms of determining the optimum interval, is the recognition that coherent information you understand, is forgotten much more slowly than nonsense. And people know that intuitively, of course. So anyway, that's one of the key insights there.
Yeah, that's such an important point. If I just go back here, like the forgetting curve, I think Ebbinghaus didn't actually draw the curve. He just had tables of data. But when you construct the curve that Ebbinghaus had from remembering these nonsense syllables, just like random strings of letters, it would have been much more precipitous of a decline. The memory would have declined much more quickly because it's not being attached to anything coherent stored in your prior knowledge, right? So it might have been the case that, Ebbinghaus was close to creating spaced repetition, but he saw the precipitousness of the decline. He thought, there's no point. It's just hopeless. We're always going to be screwed by this problem of forgetting. But
so there you go. Learn only coherent information if you want to change the world.
Exactly.
That's a key insight.
Don't learn if you don't understand. There you go.
That's right. Exactly.
So this Wozniak's research, it culminated in this serrated set of forgetting curves. I think this is a pretty classic image because when you search for spaced repetition, this is like the #1 that comes up. And just as a side point, it comes from a very, very good article by Gary Wolfe in Wired magazine called "Want to Remember Everything You'll Ever Learn, Surrender to This Algorithm." And that's like the #1 introduction to Piotr Wozniak and spaced repetition that I'd recommend because it's entertaining, it's interesting, gives you a look at the life of a very wacky scientist. So go and read that after this presentation if you're interested. But what it demonstrates is the magical property of human memory, wherein memories last longer with each repetition. So you can see the decline, the decay in the strength of the memory is very fast to begin with at the first repetition. And then, with the second repetition, you have more time where you can retrieve it. And then that just extends over time with each repetition. And it keeps extending to the point where you can actually create memories that will outlive you. So let's say you're like 60 years old. It's possible that you could have a piece of knowledge stored in your collection of Q&A cards that has an optimum interval of like 60 years. So double your lifetime. So it's likely to just persist for the rest of your life until you die, unless you live to 120, I guess. You're very healthy. So
that'd be great.
In this sense, you can redefine spaced repetition as like the most effective way to get memories to enter this permanent store where you don't even need to repeat them anymore. They just stay there. And that's a really interesting and beautiful thought. And it's actually possible to achieve this for a staggering number of question and answer pairs, a staggering amount of knowledge. So I can't remember the exact number, Zander.
I'll just say.
Go ahead.
Yeah, well, actually, I think I can guess what you were going to say. Something about the number of reps or something like this.
I was going to say like the number that's possible to maintain your memory is like around 300,000. I think was Wozniak.
Yeah, I think that's what Wozniak has stated before. But I just wanted to mention this is ridiculously efficient. Like once you try this, you won't even believe how efficient it is. There's basically the limiter on it is not the number of items that you can store in your memory or review, because you can't possibly make enough items. Like it's hard to conceptualize before you've tried this, but making enough items on a daily basis consistently enough that you'll ever hit 300,000 is basically a fantasy. Like, that'll never happen almost. You know what I mean?
Yeah.
That would require extraordinary consistency and dedication. Maybe a few people in the world have a life setup that would provide that.
Right.
But it is ridiculously efficient, and you won't believe how much you can remember this way, especially, and James kind of showed a couple of screenshots from SuperMemo. SuperMemo 18, the latest one, is running an algorithm that is at this moment proprietary. It was invented by Wozniak, as all of the currently used, at least the popular space repetition algorithms were. For example, Anki runs on SM2, and most implementations of that, most implementations of space repetition run on SM2, which was invented in, I don't know, 95 or something. But SuperMemo 18 was created in 2018, 2019, something like this. And its efficiency and its algorithm growth over time is remarkable. So it's hyper efficient, and you won't believe it.
Yeah. So we're talking like about 300,000 question answer pairs, which sounds like a lot, but from day to day, even if you let's say 100,000, because I do know a couple of people who have reached that amount of items, they're only doing like 10 to 20 minutes of repetitions per day. They're not like crushed under this huge workload like you see with the medical school Anki people and people studying, for example, for Jeopardy and stuff like that. They're not doing hours and hours per day. They're literally just doing 10 to 20 minutes, but they've been doing it over decades. So the workload is very low.
Yep, exactly.
So that what we showed there just before, the serrated set of forgetting curves, that basically refers to a single memory. Let's consider what it means across your entire knowledge base, all of the knowledge you have. So without spaced repetition, you hit basically this unavoidable plateau because of the problem of forgetting. At a certain point, the rate of learning new knowledge, this rate of acquisition, gets balanced by the rate of forgetting. And so you just reach this plateau where it's very difficult to move beyond, because the more you learn, the more you forget, the more you have to review. And so just without spaced repetition, without reviewing things in an optimal manner, it becomes very difficult to move beyond a certain point. But as soon as you have the spaced repetition algorithm and you apply it and you review the knowledge according to an optimum schedule, it basically allows you to eliminate or minimize, let's say, the downward force of forgetting. And at this point, the limiting factors become how well are you able to acquire knowledge, not how well are you able to retain it. Knowledge is being retained because you're using spaced repetition. So now you can focus on the acquisition part, where there are a bunch of interesting factors. For example, Zander, you're interested in formulation, the formulation of items, how you syntactically structure your cards, how you arrange them. That's going to play a big role, a much more significant role once you're using spaced repetition, because now you're focused on acquisition.
Yeah, exactly. And people view what you're talking about, this term formulation. It's essentially just how your flashcards are written. People view that as just like a natural thing, like, oh, I want to remember this fact, so it'll be obvious how to structure that into a flashcard. It's not obvious, and especially if you want to do it in a way that matches the way that the brain works and what will be optimal for your memory, it's quite a difficult thing to master. So it's an important topic. But anyway, yes, this concept, what you're talking about here, not only does it allow you to learn more over your lifetime, because you're not having to combat your forgetting with new learning all the time, but also if you look at how you understand something new and how you learn something new, it's always based on prior knowledge and understanding. And so the more things you remember, the more things you have in your memory bank, the easier time you'll have solving a new problem or understanding a new thing. And so therefore it changes the structure, it changes the shape of the problems you can solve and the things you can learn as you add more knowledge to your memory. So that's an important point. And it also relates to this idea that I'm sure we'll touch on later, but people talk about how all you really need is essentially access to a personal wiki or something like this, like Obsidian, and therefore it all works fine because you have this interlinked network and all these kinds of things. But to me, that is obviously not, and I apologize for saying obvious. I understand why somebody would think differently in this way, but to me, that can't be the case. You need knowledge in your memory to make use of it. If you want to come up with a new idea, that can only happen if, two seemingly disparate pieces of information are in your brain at once in such a way that they can be connected in a new way. So I think having the knowledge in your brain cannot be replaced by these networks or these backlinked, Zettelkasten systems.
Yeah. Actually, that leads in quite well to this slide, which is on why memorize. So what we've discussed so far is the possibility of memorization. Memorization is made possible through this spaced repetition algorithm, but we didn't really, we touched on briefly like why you would want to do this. What's the whole purpose of doing it? What benefits can it give you? And so let's talk about some common misconceptions that people have of memorization. The first one that I hear a lot is that memorization is just learning by rote. I also hear a lot that I don't forget things that I've understood. I think we talked about that earlier. Memorization is useless for STEM, like mathematics, scientific subjects and stuff like that. And then the one that you just touched on, Zander, Google, Obsidian, Roam, note-taking, etc. They make memorization obsolete. So in the next few slides, we're just going to address these misconceptions, I think, one by one. So to begin with, there's a misconception that memorization is just learning by rote. But I think this is kind of confused because memorization actually supports associative memory, which is like the whole thing that underlies the most desirable operations of the human mind, things like problem solving and creativity. By memorizing facts, knowledge, interesting pieces of information, what you're doing is acquiring the building blocks for your associative memory to create connections between those building blocks and create new novel information. And by creating something new, novel, and that hopefully has utility, what you're doing is something creative. You're creating something that no one else has created. So I think what people do is they confuse memorization and learning by rote because they think that people are learning things that are just useless trivia, things like learning the world's capitals, pub quiz knowledge. But by learning like highly applicable, abstract, fundamental knowledge, what you gain is the ability for your associative memory to make these very valuable, useful connections that can actually result in interesting research, inventions, business ideas in the real world, things that can actually have an effect in the real world.
Absolutely. And it's just so, if you think about this for a little while, you'll observe that any problem solving that you do in your day-to-day life or any creative thought that you have, it's all made possible by the existence of prior knowledge and understanding and concepts that you built up through learning and forgetting over time. So this is the core thing. You cannot solve problems that are related to something. Like, try being a programmer when you don't actually know anything. Like, you're Googling literally everything. Yeah, you can do some stuff, but your problem solving capacity is extremely limited. I'm not saying to memorize all the syntax and all the API operations. I'm not saying that. I'm just saying you need to understand the basic concepts. You need to have those concepts in your memory so that you can deploy them where they are needed. And this idea that you can just Google it or you can just look it up in your Zettelkasten, it's a fabrication. It's not true.
Yeah, I think I talk about this in the next slide. Yeah, the importance of memory for creativity and problem solving as well. What you require for those sorts of operations is like a fluid access to memories that are stored internally. You can't be just like Googling things in the middle of having an idea. It's too slow. You need that fast, fluid connections between ideas stored in your mind, and you also need large amounts of like abstract inference rules that you can use to combine these pieces of knowledge and move from A to B in problem solving and stuff like that. So yeah, like two facts stored in the human memory can instantly be put together and bring in your idea to life. But facts that are just sitting in your Obsidian vault, they remain useless until you connect them inside your mind. It has to be an internal process, at least now. I mean, we could in the future have AIs with creative minds, right? But at least for the present moment, the human mind is the only thing that can do this right now. And also,
I've seen some videos of some crows. They can solve problems as well creatively.
Oh, really?
But that's beside the point. Anyway,
Okay.
Go ahead.
Okay. Yeah, the final interesting point about human creativity is that a lot of it is unconscious. So I'm not sure I couldn't tell you about like the proportion, like how much of your creativity is just happening in the background while you sleep or while you're not even consciously thinking about it, and how much is conscious. But I would wager that most of it is happening while you're unconscious. So that is a huge amount of time where your brain is just trying to make connections by searching through your memories and trying to find interesting connections to make. And if you're not focusing on your internal memory and storing interesting things in your memory, you're really going to hinder that process, I think, because it's unconscious. It's not like you have access to your Obsidian Vault or personal knowledge management system while that process is taking place. It has to take place internally inside the mind, right?
Yeah, you need to be able to plug a USB drive with your Obsidian Vault right into the back of your skull.
Exactly, yeah.
So you can process those files while you're
We need the Neuralink plug-in as soon as possible.
ASAP, please, someone do it. Thank you, Elon. Come on.
So here's like a quick diagram just to sum up what I mean about sort of focusing on the internal memory rather than separating your internal memory from your external store of information and interesting notes and stuff like that. This is what it looks like with the Zettelkasten approach, and obviously this is this is a generalization, because obviously when you're using your Zettelkasten, some of it is going to get retained in your memory, obviously. It's just not systematic. I think that's the difference. It's not systematically trying to compute optimum intervals and everything like that to optimize for storing useful information in your mind. It just happens incidentally. And so the difference with an SRS is that everything is set up in a way to optimize for this process, to make it as smooth as possible. The internal memory is given priority over everything else, and the external storage, linking, doing backlinks and stuff, while that is useful and it does have a place, I'm certainly not saying that it's useless or anything like that. It's just that the SRS doesn't focus on that at all. It focuses 100% on storing things into your mind.
Yeah, absolutely. And there's a great interplay between these things if that's because, like we talked about, actually, first of all, I just want to say I think there may be a typo for the word Zettelkasten in the previous slide.
Oh, sorry,
but
my bad.
Anyway, no, it's all right. I just want to note it. Anyway, like we talked about, now that you can essentially remember anything that you learn, the bottleneck is like, well, there's open questions, which is like, what should I learn? What should I remember? How do I understand things better so that I can capture that understanding in a set of spaced repetition prompts, these kinds of things. And this is where the Zettelkasten can have a perfect role in this. And so you use the Zettelkasten and the notes to develop your understanding, connect ideas together, and then whatever falls out of that, whatever ideas, whatever understanding, whatever it is, you can then capture that in a set of spaced repetition prompts, just so that you don't forget it, so that you have it in the mind, so that you can build on it creatively, these kinds of things. So the interplay between them can be just absolutely perfect. And I think that's such a worthwhile thing.
Yeah, I really like that point. It comes back to what we were saying earlier. It seems silly to say that it's worthwhile to remember your own ideas, but it really is, to memorize your own ideas. It's very useful, and
exactly,
you can generate new insights based on your old insights and develop them over time. It's a very worthwhile approach for sure. I think this is the last slide,
and it doesn't.
Oh, sorry. Go ahead. Go ahead.
I'll just say this real quick. Your Zettelkasten is not limited to like original ideas that are your own. It can be like written in your own words, an idea that you're trying to learn about, and then you can use that understanding that you've built and make space repetition prompts to maintain that understanding. So it's not only for your own ideas, but that certainly is a core component of it. Anyway, go ahead about this.
Yeah, this is just the final slide, and I think it basically says what I said in the slide about creativity. It's just that efficient problem solving as well depends on you having a large base of knowledge, and also these abstract inference rules to connect that knowledge together and allow you to solve problems to go from A to B. It just seems that by memorizing things, you can maximize the potential for your associative memory to make new connections, and all of those things. The increasing your ability for your associative memory to make connections is good for all of those valuable operations of the human brain that we really want to promote, like creativity, problem solving, coming up with new ideas, making new associations, and so on. And so, yeah, that's the final slide. And just at the end, I wanted to put a couple of recommendations for further reading. Number one would definitely be that article by Gary Wolfe in Wired, Want to Remember Everything You'll Ever Learn, Surrender to This Algorithm. It's great. Again, I think I mentioned it earlier, but yeah, it's just a great look into the life of a wacky scientist, and talks a lot about the algorithm.
Into the life of an absurdly dedicated man.
Yeah, exactly. And then secondly, I couldn't do a presentation relating to SuperMemo and spatial repetition without recommending supermemo.guru, which is Piotr Wozniak's wiki, his main wiki. He's got a few, but this is the main one with a bunch of information about spaced repetition, and it's like the Bible of spaced repetition, I guess. And it's even got stuff about sleep, creativity, school system, diet, everything really. Yeah, exactly. It's like his whole philosophy in that.
Yeah, it's his public. Imagine if he just made his Obsidian vault public. He doesn't use Obsidian; he uses SuperMemo for this. But yeah, it's just a public version of his own ideas developing, and they're not only about spaced repetition and learning, but they're about like diet or the school system or what happens to your eyes if you wear glasses or like these kinds of things.
Barefoot running.
Yeah, exactly.
And then finally, if you're like more academically oriented, you should check out Gwen's Spaced Repetition Literature Review, which goes over all of the academic papers. Although I will say that I think we briefly mentioned this earlier, a lot of the spaced repetition papers aren't that interesting because they focus on memorizing either it will be language learning stuff or stuff that's as close to nonsense syllables, Ebbinghaus-esque nonsense syllables as possible, which just makes for very dry reading. It's not that interesting. I think Woz has some stuff on the theoretical side of spaced repetition as well, if that interests you. But we can give further recommendations if you ask in the discussion as well. But yeah, I think that pretty much sums it up. Zander, do you have anything else you want to say? Or
no, yeah, I think that's great. And I definitely recommend that Gwen article, even if you're not too interested in reading the papers themselves. Gwen does an excellent job, as he always does, putting that stuff together and adding some commentary, so it's easier to get the bigger picture without doing the work yourself. So absolutely. I highly recommend that article.
Yes. All right. I think that pretty much sums it up. Thanks for listening, and we can do like a discussion now if you want. And yeah, any questions you have, feel free to pose them.
Sorry, dropped my rock. Thank you,
no problem.
James and Zander. That was really interesting. Personally, you guys have converted me. I'm going to try this out by myself.
Oh, wonderful.
Yeah, like I was on the side that I don't have to like remember lots of facts and figures. I've got more like more abstract stuff that I have to work on. So I don't think I need this, but like you make very interesting points, and I'm going to try this now.
Awesome. Really glad to hear that.
So thank you guys for doing this presentation. We're going to have this discussion now. So anyone can post questions in the chat, and if you are comfortable, you can turn on your mic and or camera to ask a question.
I've got a question, or two questions actually. One is, what exact tools do you use to do this? Like what software tools or whatever? And secondly, I take in an enormous amount of information every day. Like I sleep 4 hours in 24, and the other 20 are probably just taking in information because I never watch television. So the difficulty for me would be choosing what to actually put into spaced repetition. This is a problem I've had in the past. Like, with all this, fire hose of information that's coming in, how do you choose what you're actually, putting onto Anki cards or, however you're doing this?
Yeah, so I'll answer for myself, and then James can go on. I'll take him in reverse. So in terms of what to put into the system, I would say a lot of it comes from experience, which is to say, if you put in a bunch of items, over time you'll realize like, oh, I didn't really make use of those. And then you can use that new information and your brain will build some kind of generalized pattern of what it looks like when you're trying to make an item or a prompt out of information that's really not going to be useful to you in the longer term. So a lot of it is just getting experience over time and creating way too many prompts, and then over time you realize like, oh, that was useful. I didn't ever make use of that, and so you titrate it that way. But also another piece of it is a deliberate focus on applicability, which is to say like, is this going to affect my day-to-day life? Will I employ this information in my work or for some creative project or whatever it is? And so it's those kinds of things. And one of the shortcuts to improving the average applicability of your prompts is to make prompts out of learning that you've done for a particular project. So if you need some information about some subject for something you're trying to understand, or a new type of coding project you're trying to take on or something like this, you can then make prompts from that. So not only because they're going to be useful because they already have been. So that is automatically a shortcut to getting to a better quality of item. So those are the 2 points that I would say. Just try and think to yourself all the time, am I going to use this? What's the applicability of this? Am I just hoarding the knowledge for the sake of it? I know a lot of people have that mindset of like, I'll just remember every single thing I come across, it's really a waste of time. Just because something's interesting doesn't mean it's worth remembering. And over time, I think you'll develop an intuition for that. Unfortunately, I'm not sure how to get that up front or if it's even possible, but I do know that keeping these certain principles in mind of, project-based learning and maintaining a focus on applicability, stuff like that, those can be great tools there. And then the first question in terms of what I use to do this, I personally use SuperMemo, and I also develop a project called Dendro with a couple of co-founders. You can find it at dendro.cloud if you want to check it out. But anyway, it's basically SuperMemo's incremental reading system. We're trying to make that more applicable and add on some new idea or more accessible, and add on some new ideas there. So those are the two that I use. But the reason I use SuperMemo instead of something like Anki is because the algorithm is much better and it has incremental reading integrated with it, which we didn't get into incremental reading today, but that is a very, very interesting thing as well. And people here would be interested in that. But anyway, those are the two reasons why I use SuperMemo and not Anki. The algorithm difference for reviewing the items is huge. At least for me, it's at least 2 times as efficient. So those are my answers there. I'd be curious what James has to say about that.
Yeah. I guess I'll take it in the reverse order as well, the same order as you did. So in terms of what things to encode in the spaced repetition system, I think it's difficult to say, and we have this conversation a lot. Like me and Zander are both part of a Discord channel called the SuperMemo.wiki Discord channel, where it originally started as like a SuperMemo focused Discord channel, but now it's just become more of like a general hangout for people interested in spaced repetition. But one of the main topics that we discuss is like what's worth remembering, and I think what I'd say just to you now, just briefly, is I think the most important thing is to remember things that you enjoy, that you will enjoy reviewing. Because it sounds like you mentioned just before we started recording that you're a retired programmer. It sounds like you're continuing to learn out of like self-interest, out of pleasure, out of enjoyment, because you enjoy learning. It would be such a shame to destroy that by forcing yourself to sort of go through this miserable grind of every morning of doing your repetitions and feeling like you're a worker at the flashcard factory, just hitting the space bar and hitting next repetition and so on. So I think let pleasure be your guide, and just if you see something and you think that's given me a good idea, or that's such an interesting insight, I think that makes it a good candidate for formulating it as a flashcard, because if you in the moment you think, oh, that's so interesting, it sort of suggests that you're going to enjoy seeing it again over time. It's like I think that's the best way to make sure that your spaced repetition sessions stay interesting and stay fun, and that will also make you more motivated to spend more time doing it, to spend more time learning, and I think that will just lead to you having good results over time. You might notice that perhaps there's like a disconnect between things that are applicable and useful and things that you find interesting, but you can like address that down the line. I think to begin with, at least, I'd recommend that you just enjoy your learning. Yeah, for sure. And then in terms of tools, I use SuperMemo as well, like Zander, but I didn't start with SuperMemo. I started with Anki, and I used that for around 4 years when I was in high school. So that was a good introduction to spaced repetition, and it's certainly reasonable to use Anki. I'm not like a SuperMemo elitist or anything. It's just SuperMemo is better in a lot of ways, especially in terms of incremental reading, which yeah, like Zander said, we didn't get into it today. It's a whole nother presentation. I have got a video on it on my channel, Experimental Learning, if you want to watch that.
Oh, that's a fantastic video. Highly recommend
that. Yeah, so check that out if you want to. But yeah, there's a lot of information out there about Anki, so it makes it more easy to get into. There's a lot of add-ons. I imagine there'll be some sort of plugin integration with Obsidian that would allow you to do some interop between Obsidian and Anki. So perhaps that's a good place to start if you're interested in getting into this.
Yeah, yeah.
Thanks,
I didn't
guys.
start with SuperMemo either.
Thanks, guys. Great advice and great talk. Appreciate it. Thank you.
Thank you, Paul. Thanks.
Thank you.
I've got a couple of questions. The first is, so using your advice from the previous question, you choose which information you want to put into your deck, your database. But then on the card, how do you decide like which information should be the prompt and what should go in the answer? Like, because to some extent, putting some of the answer on the prompt is like giving yourself a hint, but then you're not remembering as much, you know? So that's my first question. Maybe we can comment on that. And then any recommendations on integrations with Obsidian? Because I've already got all this stuff there. So I'd like to do as little migration as possible. Yeah.
Yeah, you want to take that, James?
Yeah, sure. I'll quickly say something about the integration with Obsidian. I've not personally used any of the plugins that integrate Obsidian and Anki, but I know they exist. So that's the first place I go. Actually, I think Brian Jenks possibly. Yeah, it was Brian Jenks. He has a video that it's called like the state of spaced repetition in Obsidian, and he basically talks about all of the different integration options that you have for doing spaced repetition in Obsidian through plugins or integrating with Anki as well. So definitely check that video out. And then you also asked a question about structuring your prompts, how to avoid hints and stuff like that. The analogy that me and Zander have talked about before is like, you know, prompt writing is very difficult, and you almost have to train yourself like an AI on lots of data. You need to create lots of prompts, realize which ones work and which ones don't, and slowly sort of tune your prompt making model over time to the point where you're making good question and answer cards. But just as some like general advice, like you can try and structure your prompts in a way that you can try and predict either like the real life scenario that would that sort of matches the prompt. You can try and match the prompt to a real world scenario where you'd want to recall the information in the answer, if you know what I mean. So that's one way to do it. And also there's a really good classic guide by Piotr Wozniak called The 20 Rules of Formulating Knowledge. It's like the #1 article on, designing flashcard prompts, I think, right now. That there's very little writing about it in general, but that's probably where I'd go. And he has some examples. He walks you through a bunch of just general heuristics for card making. But I think Zander probably has more to say about this. He's much more interested in the formulation side of things. So go ahead, Zander.
Yeah, and well, first of all, on the Obsidian integration thing, I just want to mention James. I don't know if people are aware of this, but James has made an incremental writing plugin, which is obviously different from spaced repetition, but in the more generalized way we were talking about it in terms of a scheduler, it schedules your notes to come back to you. So you can imagine many scenarios where you don't have something new to add to let's say an idea right now, but maybe if you looked at it again in a couple of weeks, you would. And so orchestrating that manually is quite difficult. So James's plugin is meant to replicate a feature that SuperMemo has called incremental writing, but it's in Obsidian. It's very well done. So that's one integration, although it's not perfectly matching what we're talking about here. But anyway, so that's that. In terms of the formulation, people that I will essentially talk to anybody that wants to talk about this, because this has been an obsession of mine for over half a decade. I've thought about this every single day of my life, and it not to demoralize anybody, but this took me a lot of thinking, and maybe I was just looking at it the wrong way, or there wasn't enough writing. And in fact, I'm hopeful now that if someone started, they could get to a level of expertise much more quickly, given how much more it's talked about. Because I started thinking about this in like 2014. I guess it's been even longer than I thought. And there wasn't much, people didn't really even recognize this as an important thing to optimize. So anyway, I don't think that should demoralize people in terms of how long it took me. I think you can get there much more quickly. But it's a crucial point, because if you get this wrong, you'll still forget all of your items, and it'll be a slog, because a lot of beginners, for example, they make spaced repetition prompts. Henceforth, I'll call them items just because it's quicker. They make items that include multiple questions in them. Essentially, they're asking themselves to recall multiple pieces of information, and that can be very time consuming. But the worst part is that it's not effective at all. You need to uniformly activate all of these synapses that are involved in a particular memory. And if you're trying to spread the activation across multiple memories, it's not going to activate it well, and the strength increase in the memory will not be as significant, and you'll probably forget the item over time, or something which Piotr Wozniak calls pattern matching, or pattern extraction. Something he calls pattern extraction will occur, which is you review the item and you only remember one piece of it, or you see it and you instantly remember that one piece. That's all you can know. So anyway, that's the point of what I'm saying, is that beginners make very many mistakes, which increase the time consumption of reviewing items, increase the difficulty massively, and increase their forgetting of the items in such a way that they start to feel like this doesn't work. And sometimes you can even get this scenario where you're writing good items in the syntactic sense. You remember them when you review them, but because they're not phrased in a useful way, or like Ross mentioned, they provide too many hints, that it can mean that when you encounter a similar situation in life, you won't actually think of it, because the review context doesn't match the real life context. So there's all kinds of problems, and it's really, really worth optimizing for it. Like James mentioned, there's an article by Piotr Wozniak called The 20 Rules of Knowledge Formulation, or something like this. There's also another one by him that was written in the late 90s, which people barely talk about. And to me, it's one of the best resources on this in existence. I don't remember the exact title, but it's got knowledge structuring in the title. If you look up Piotr Wozniak knowledge structuring, you'll find it. It's about economics. The items, as an example, are economics, so you'll know if that's the one. But anyway, those are two great resources. A newer resource, which I think is tremendous, is Andy Matuszak's article on how to write good prompts. I believe the URL for that is andymatuszak.org/prompts. So that would be a fantastic resource. And if you're into this kind of thing, he integrates his system called Orbit, which is essentially you can embed spaced repetition items into a page and then review them. So the article will have one section and then a bunch of prompts that he wrote to help you remember the stuff in that section. And then it'll email you whenever you have items to review. And it's a really well done service. And the core point there is that not only is his article very insightful, but he'll do the work for you of writing the good prompts about how to write good prompts so that you can maintain that over time. So anyway, those are some good resources. And also, if anybody wants to talk about this, or actually, we talked about this on the podcast a lot, so that might be a useful resource. But also, just let me know. I'll talk to anybody about this because I think this is the crucial skill, and if I can lend any expertise to people, I'm happy to do that.
Awesome, thank you for the answer. So just what I took from that is make the prompts like as real world applicable as possible, so that that memory is triggered like the most easily. And at least for me, counterintuitively, I would think that giving multiple different questions or prompts would make it easier, but it makes sense, as you said, Zander, that it would like fragment the activation of that. Very interesting. Thank you.
Yeah, absolutely. And actually, since nobody has an immediate... Oh, do you have something to say, James? Go ahead.
Oh, no, you go ahead.
I was just going to say, since nobody has an immediate question, I just want to elaborate. Like a couple of principles you can follow is one that I stated there called the minimum information principle, which is essentially one question should have... Each item should be about one thing. And so that's one core point. Another core point is to simplify the wording as much as possible. When you're reviewing these prompts, if you have many of them to review, let's say 50 in a day or something like this, your attention is the core point. So you need to simplify the wording as much as possible to make sure that your attention, your concentration is always there. And longer prompts with kind of convoluted wording can really dull that and make it much harder to activate the memory properly. So keep them as short as possible, keep them about one thing, these kinds of things. Try to replicate real life scenarios, which often means getting rid of a lot of hint phrases that people use. Another thing, and maybe this is what Ross was getting at some level, you can make redundant items. So it's phrased slightly differently, but it gets at the same underlying thing. And that can protect you against forgetting. Sometimes it can be quicker to remember 2 or 3 items about one thing than to remember one, because the fact that there are 2 or 3 protects you from forgetting any of them. And so once you forget an item once, it then has many more repetitions because the algorithm knows that you had trouble with it. So it can be much more time consuming. All that to say, redundancy is a good thing there. Anyway, those are some principles right away that would be hugely useful to employ.
Yeah. If anyone's got any more questions, go ahead. Otherwise, this has been a really fun presentation, and I guess we can call it here.
Yeah. Certainly, if anybody has any questions, let us know. But otherwise, thanks for having me, guys, and thanks, James, for inviting me here. I certainly wasn't expecting this, so this was fun.
For James and Zander, is there somewhere that people can contact you if they've got questions afterwards?
Yeah, you can message me on Twitter if you want, or Discord. Like James said, we frequent this Discord, SuperMemo.wiki, so you can find me on there if you want. My Twitter is ZDRKS, so you can find me there. But yeah, like I said, I'm always happy to talk about this, anything surrounding this. And yeah, I would welcome that.
Yeah, I'm the same way, just Discord or Twitter. Attic Learning, either one, go ahead.
Awesome, thanks. And I'm actually going to check out you guys' podcast. I love some podcasts about knowledge.
Awesome, thank you.
Yeah, it'd be cool to have on some Obsidian pros as well. We haven't had like a Obsidian expert on at all before, so yeah, that's an open invitation.
Dude, we gotta get somebody on. If any of you guys wanna do it and you feel like you have something interesting to say, let's do that.
Yeah, sounds like a good collaboration. I'm sure you get some interest on the Discord.
Absolutely. All right.
Awesome.
Well, this was wonderful. Good talking to you guys. Thanks again for having me.
Yeah, thanks everybody.
Thanks for coming. Yeah, thanks James. Thanks Zander.